Okay, B1 Bob, here's the updated version of that drawing as well as updated video. And what I had to do was add, because in my design I originally used relays. And in this case I used a latching relay, but in this case we're not using any relays. So we had to go at this a little different way. And what I've done is I've used diodes. Now what a diode is it simply allows electricity to flow in one direction, or DC current to flow in one direction. So you have to make sure you put the diodes in the proper way, and then the system will work. If you don't put them in right, then of course you won't get the result you're looking for. And in this case I'm actually using two different ones because I didn't have two of the same size. And the small ones will work just fine for what you want to do. You can pick them up at Radio Shack for a couple bucks maybe. But at any rate, you'll go ahead and wire these in, and you'll wire the switches. I'll give you the diagram. I will redraw the diagram so that you can follow it. But I wanted to show you this working. Actually, I took a tool that I made to drill holes in the center of dowels, and I'm just using it. Now you obviously won't be able to tell that it's running in reverse, but I can assure you that it does back up. Also, what I've used is a simple on-on switch, and what that means is that there's two sets of poles, and if you throw the switch in one direction, it connects the poles on this side together. If you throw the switch in the other direction, well, it connects the other side together. Here you can see that I've actually wired in the X connecting this leg and this leg together, and this leg and this leg together. And of course I'm feeding the power in from the center on the poles, which are in the middle here, positive on one side, negative on the other. It doesn't really matter which way you go, because ultimately the end result will be reversing the wires at the actuator if you find that they're running the wrong way. So with that, that's how I get the reverse direction right here with this switch. You can use a servo to actuate the switch. Again, this is a on double pole double throw switch, and it'd probably be best for you to use it because the travel is a lot less. At any rate, the way this is going to work, right now I have a second switch on my device over here. I'm going to go ahead and turn that switch on. Now you can hear the motor running. Now if I throw this switch, it's just going to reverse direction. So what I want to do is figure out which switch it is that is operating the actuator or going to stop it, because it's only one of the switches is going to stop it. So you can figure that your gear is moving up. So we got to find the switch that it's going to hit whenever it goes fully up. And it would be this switch right here. So notice if I touch the switch, activate the switch, it's turning the motor off. Now if I do this one over here, you see nothing's happening. Because remember, in your situation, whenever it stops, this switch is going to be closed. Or in this case, it's going to be opened. So you really need the gear to start moving the other direction as soon as you throw the switch, which I'm going to do now. So notice whenever I throw the switch, you'll hear that motor start running again, but now it's going to be running in the opposite direction. And again, this switch up here I'm going to keep closed. So now I'm going to throw this switch down here. Now it's going in the opposite direction, and you can see this switch doesn't have any effect on it. However, whenever the gear gets all the way down, then it would hit this switch and stop it. So again, if you hold this switch closed, this one here has no effect on your actuator. So again, I'm going to throw the switch. This would bring the gear back up or down, whichever the case may be. But at any rate, notice the motor started running again, but I still have this switch closed. But once again, as soon as the gear gets all the way in the retract or all the way in the down position, it hits this switch, and of course it stops it. So that's how you're going to, how I would recommend you go about wiring up your actuator. So again, if change direction, this switch right here does all the work. This switch down here is going to stop the motor. Change the direction. This switch right here is going to stop the motor. So that's how you go about wiring up this little device you want to wire up, and again, you're just using a couple of small diodes. You don't really need anything big. So I hope this helps, and between this video and the drawing, you should have enough information to wire up your system.